All right, these are the answers to the review for the quiz 9193. For the first two here, we're starting with n equal 1 and coming up with the first 5 terms. So as far as the first term, we're just putting 1 in. 1 factorial is 1. 3 to the first is 3, minus 2 is 1. So we get 1 over 1 or 1 for that first term. Put 2 in, we're going to get 2 factorial over 9 minus 2, which is 7. Put 3 in, we're going to get 3 factorial, which is 6, over 27 minus 2, which is 25. Put 4 in, we're going to get 24 over 3 to the 4th, 81 minus 2, which is 79. And then put 5 in, we get 120 over 81 to 243 minus 2, 241. So again, we're just throwing in 1, 2, 3, 4, 5. Same thing here. If I put 1 in, I'm going to get a negative 4 times 1, so negative 4 over 1 squared plus 1, which is 2. So obviously it could be negative 2 there. If I put 2 in, I'm going to get a positive 8 over 2 squared plus 1, which is 5. Put 3 in, now I get negative 12 over 3 squared plus 1, which is 10. Put 4 in, I get 16 over 17. And then I put 5 in, I get negative 20 over 26. Again, some of these can be reduced for sure, but all we're doing is throwing 1, 2, 3, 4, 5, and so on. For 3 and 4, now we're trying to come up with an expression that would give us this. And so if I'm starting at n equal 1, I'm looking here and I see that the top is going in an alternating pattern. So a sub n will equal negative 1. I want it to be even when n is odd, and odd when I want it to be positive when n is odd, and negative when n is even. So that means I'm going to have to add 1 to this or subtract 1. And that gets the alternator on onto that cycle. If this had been negative, positive, then it would just be n, similar to what we had on number 2. Okay. Then you notice that at the top is just going up by 1, so it's always 2 more than whatever n value you're at. So this is going to be n plus 2 for the top part. And then the bottom, this 1, 2, 6, 24, 120, we saw that earlier on number 1. That's just n factorial. So we want to start recognizing that and be able to kind of write that out. Same thing here for number 4. You see that we have x to the second, x to the 4th, 6, 8. This is just 2 times whatever n is, so it's going to be x to the 2n on the top. And then on the bottom, we have 1, and then 8, 27, 64. Well, this is 1 to the 3rd, 2 to the 3rd, 3 to the 3rd, 4 to the 3rd, 5 to the 3rd. So this is just n to the 3rd. And again, that's really about recognizing and understanding what we're dealing with in that. All right, these next 3 here want us to find the convergence or divergence of the sequence. So we're just talking about a sequence. What does this go to? If we let n get super, super big, see how we have n to the 5th and n to the 5th? They're the same magnitude. So over time, this will just gravitate to the ratio of this. So this will converge as a sequence to pi over e. Okay, not talking about a series right now, just talking about the sequence itself. All right, number 6. We're going to continually multiply by 3/4. This is what's called a recursive formula. It means take whatever you had, multiply by 3/4, that'll get you the next term. Well, if we multiply by something less than 1, it's going to continue to get smaller and smaller and smaller, and so this will converge to 0 over time. For number 7, I have 3 to the n over n to the 100th. If you were to do, say, like a L'Hopital's or something to see, this 3 to the n is going to continually stay up top as you take the derivative of it over time, whereas this will start to peter out, if you will. And so we have kind of a ranking, if you will. Factorial expressions are always the most powerful. Those are greater than exponential expressions. Exponential. All right, which are greater than polynomial expressions. So whenever you're kind of comparing the strengths of these, factorials will always beat exponentials, exponentials will always beat polynomials. So in other words, this on the top will grow significantly faster than this will over time, therefore this diverges, this goes to infinity. And then number 8 is going to give us a sequence that goes 5, -5, 5, -5, 5, -5 forever and ever and ever. And so this doesn't converge to any one value, but it also doesn't go off to infinity. So this diverges, it just diverges in a different way than this one. This one went to infinity, whereas this one oscillates between 5 and -5. So we never converge to one thing. We also aren't going off to some great giant value either. Now we wanted to find the summations for these here. For number 9, we're adding up the terms from n = 4 to 7. So if you put 4 in, you're going to get 5 minus 12, you're going to get -7. Plus put 5 in, -10. Plus put 6 in, -13. Plus put 7 in, you get -16. All right, if we add these up, we're going to get a -46 for that. For number 10, we're adding, but this is going to continue, go forever and ever. And we notice that to get from term to term, we're going by a half. So this is a geometric series, and it has an R value of 1/2. So because it has an R value less than 1, it's geometric. The infinite sum of this, the sum of this will be the first term in that series, which was 50, over 1 minus the R value. So this is going to be 50 divided by 1/2, which will give us 100. Number 11 is also a geometric series. You can, if you kind of pull the 4 off to the side, or kind of think about it written like this, it's 4 times 1 over n to the n plus 1, right? And so this is a geometric series with an R value of 1/9, so that's less than 1. So this is also going to converge, and it'll converge to the first term. So if I put 1 in, I get 4 over 81. So that's the first term of this series, is 4 over 81. All right, and then 1/9 is the R value, so it's going to be 1 minus 1/9. So we're going to get 481 over 8/9. If I flip that, make it 9/8. All right, I get 9 there, I get 2 there. I end up with 1/18 as our answer. And then this one wants to know, what's the third partial sum if this is, what this means is we want first term plus second term plus third term. That's what the third partial sum means. So if I do a sub 1, that's 13, a sub 2 is 16, a sub 3 is 19. If I add these all together, I'm going to get 48 for my answer. Then 13, 14, 15 wants to know, do these diverge by the nth term test? In other words, does the sequence go to 0 or something else? Okay. So if the sequence goes to something else, then it diverges. Okay. If it goes to 0, don't know. We need more information. Okay. But if we know the sequence doesn't go to 0, then by nth term test we can say this diverges. So on this one here, we have 2/3 plus 2/9 plus 2/27. So we're multiplying by 1/3 each time to get from term to term to term. That sequence will go to 0. That sequence will go to 0 over time. Therefore, can't say anything. I mean, we could say something more, but not using nth term test. So by nth term test, we'd say, no, this doesn't diverge. 14, if you let 2n squared plus 1 over 3n, if you take the limit as n goes to infinity, that's going to go to infinity. So yes, this diverges by nth term test. The sequence itself blows up, so will the series. And 15, if we take the limit as n goes to infinity of 2n squared plus 1 over 3n squared, we're going to get 2/3. So the sequence does converge to 2/3. However, as a series, what that means is that you're going to be adding 2/3 over and over and over and over again. And so the series will continually get bigger and bigger and bigger. So as a series, this diverges by nth term test. The sequence has to go to 0. It has to converge to 0 so that over time you've kind of settled off on some limit, some sum. If it's anything other than 0, it's just going to keep getting bigger and bigger.